This video is on separation of mixtures. So I'm going to show you or talk about different ways that mixtures can be separated. And remember that mixtures can be separated by physical means, meaning I'm not doing any sort of chemical reaction. I'm not rearranging the atoms themselves within the molecules or kind of atom to molecule, element to molecule. So we're just taking our mixtures, things that are mixed together, homogeneous or heterogeneous, and we're going to separate the pieces. So 4 common methods I'm going to go over: filtration, distillation, crystallization, and magnetism. So the first one is filtration, and you've all done this before if you've made pasta. Okay, it's taking an insoluble solid from a liquid. So solid, liquid, if that's what you have right here, you can separate them using a filter. So one filter is this setup right here, where you can see we've got the funnel, kind of highlight in yellow, the funnel right here. And then what's in there is filter paper. Filter paper is like a coffee filter where the liquid can go through, but the solid won't, and it'll stop little teeny pieces. Like if you've made coffee, right? You have coffee grounds that go in your filter, the water runs through, but the coffee grounds themselves do not go through into your cup or pot, whatever you're making. So the liquid will go through, so liquid ends up in here. Solid then stays in the filter paper. All right, your water pitcher does this if you have a filter in there. A more simple one, a more basic one, like you're cooking pasta, would be, right, you have some sort of strainer or some sort of like screen. You've all seen screens like this, right? Where as long as your pieces that you're trying to separate, your solid pieces, are big enough that they're not going to go through those holes, that works just as well and would be faster than like filter paper, where it's going to catch, filter paper would catch smaller pieces. All right, the next one is distillation. Distillation you probably have not done, or maybe you weren't really aware that you were doing it. This looks at a difference in boiling points. So oftentimes you have like 2 liquids here. So the example set up here is they start here where they have salt water. Okay, so this happens in desalination if you're trying to get salt water to fresh water, like so you could drink it or use it for cooking or something like that. You have to separate the salt and the water. But you want to collect the water. Like when we did this in class, or when you've seen this done, right? The water just evaporates. Well, what if you want the water, not the salt? You, in the process here, it goes, the water as it evaporates, right? Goes up this tube, and then it's going to go down this way. You can see it's capped right here. And this is what we call the condenser. So it's got cold water on the outside of it as the water vapor goes through the inside of it. And the cold water on the outside lowers the temperature. So it takes that water vapor, water as a gas, and it turns it back into a liquid, you can see as it goes down here. Okay, so then you collect your water this way. This could also work if you had 2 liquids with different boiling points, like the first day when I did the demo of water and alcohol and I burned the dollar bill. The water didn't burn off, it didn't evaporate, but the alcohol did, right? So the alcohol burned, but the water was still on that dollar bill because they have different boiling points. So if I had that isopropyl alcohol, rubbing alcohol, and water in this, right, container here, and I heated it to below water's boiling point, so lower than 100 Celsius, but above the alcohol's boiling point, the alcohol would go through this same process. And then I'd end up with the alcohol in this tube and just water in my top one, my starting one. Okay, so that's distillation. This is one way also that they get gasoline from crude oil. They distill it off. All right, another one is crystallization. This is kind of the same concept, like we could do this with the salt water, but we're not adding heat. We're just letting it happen through evaporation. So it's going to be slower. Making rock candy, you have your solution of sugar water, you put a stick or a string in there, the water evaporates, and you can see these right here are your sugar crystals that will stay right there on your stick, string, whatever you put in there. This happens with mineral formations in the earth. If you've seen like crystals in rocks and geodes and things like that, or like in caves, there's those minerals and things are dissolved in the water, and then as the water evaporates, the minerals are left behind, and you have those cool crystals and geodes and things inside of rocks and caves. The last one is magnetism. Magnetism is obviously using magnetic properties to separate things. So if you have a mixture of something that is magnetic, like metals are magnetic, and something that's not magnetic, you could use the magnet obviously to pull the magnetic pieces out. They sometimes use this at like recycling centers when they're trying to sort metals from other things, right? If they have a big strong metal over like a conveyor belt where all the stuff is moving past it, all the garbage or recycling, it'll pull up the metal cans and things and leave the non-metals or non-magnetic metals even on the conveyor belt. So this is a way to sort that way. So those are the four ways of separating mixtures that you will need to know.